Hello, my name's Cathie Wells and I'm an atmospheric scientist at the University of Reading. My work focuses on understanding the environmental impacts of aircraft. Speed is a measure of how fast an object is moving, and it's calculated by using the equation distance moved divided by time taken. Or we can rearrange that so that we can find time taken as distance divided by speed. If an aircraft travels from London to New York, a distance of 5,570 kilometres, at a typical speed of 237 metres per second, then the flight time will be 23,502 seconds, or just over 6.5 hours. Wind speed is simply how far the air travels across the surface of the Earth in a certain amount of time. The fastest wind speed recorded in the UK was 173 miles per hour. That's 77 metres every second. It was recorded at the top of Cairngorm Mountain, and you certainly wouldn't have wanted to be out in that. The wind speed only has to be 33 metres per second to count as hurricane force. But high up in the atmosphere, at the level that aeroplanes fly, the wind speed can be up to 123 metres per second. That's 275 miles an hour. Of course, the air can move in 3 dimensions. It can move up and down, east and west, north and south, or more usually it moves in a combination of these, so it's important to know the wind's direction as well as its speed. Velocity is speed in a given direction. Now, consider an aircraft moving through the atmosphere. If there was no wind at all, the aircraft's speed would simply be the rate at which it's covering the ground. But what if there is some wind? Depending on the direction of the wind, it'll either speed up or slow down the aeroplane. Relative to the ground, the aeroplane's velocity will be the sum of the velocity of the wind and the velocity of the plane. Let's consider the aircraft flying from New York to London. If it can fly in the fastest flowing air, the jet stream, then the combined velocity will be the speed of the plane plus the speed of the air. In this case, that would be 360 metres per second. On the other hand, if it's flying the other way, from London to New York, then the wind will slow the plane down and the combined velocity will be the speed of the plane minus the speed of the air. That's only 114 metres per second, and that's a massive difference. Aircraft have an impact on the climate through the petrol-based fuels which they use to power their flight. The faster an aeroplane can get to its destination, the less fuel it'll use, and the smaller the climate impact it'll have. Planes are already designed to make them as aerodynamic as possible, to reduce their flight times. We've been working on forecasting tools to let pilots make the best use of the wind. Maybe there's a patch of especially fast air flowing just above an aircraft. If forecasters can communicate that to a pilot, allowing them to fly up into that air, then the flight time will be reduced. The latest forecasts can provide new information to pilots every minute that they're in the air, and that could save hundreds of thousands of tons of carbon dioxide, a greenhouse gas, from being added to the atmosphere each year. For example, if we look at just the routes between London Heathrow Airport and John F. Kennedy Airport in New York, by choosing optimal heading angles, airspeeds and altitudes, we could save 3.2 million kilograms of fuel flying westbound and 3.1 million kilograms eastbound in a single winter. This would reduce carbon dioxide emissions by 20 million kilograms. You might think you don't fly very much, or even at all, but you're still reliant on aeroplanes. They bring us letters and online purchases from overseas, as well as fruit, vegetables and flowers. By making very detailed maps of the speed and direction the atmosphere is moving in, we can help aircraft make the best use of the wind, reduce their flight times, use less fuel, and so reduce the climate impacts of air travel.